Now we look at the second case. It is the case when your right hand side r of x is a sine function or a cos function. That is, suppose if your r of x is sine 2x or say cos 4x, then how to find yp. So we are looking at equations of the form y double dash plus a into y dash plus b into y equal to r of x, where r of x is, say for example, k sine omega x or k cos omega x. In that case, the choice of your trial solution, that is choice of yp, should be a cos omega x plus b sine omega x. The next step is we are actually going to find yp dash, yp double dash. We are going to substitute in the given ordinary differential equation. We are going to equate the left hand side and the right hand side, and then we are going to find these constants a and b. We'll look at it with the help of an example here. We look at the question, we look at this question here. The question is y double dash plus y equal to sine 2x. So the first thing is you have to find YH. YH is the solution of the corresponding homogeneous part. So you have to take the right hand side to be equal to 0. Okay. Now once you take the right hand side to be equal to 0, how to solve it? You have to write the characteristic equation. For writing the characteristic equation, you have to replace y with 1, y dash with m, and y double dash with m square. So your characteristic equation comes out to be m square plus 1 equal to 0. And the roots of the characteristic equation are m is equal to plus or minus I. So you are having complex conjugate roots. So if the roots of the characteristic equation are alpha plus or minus I beta, then the solution will be e raised to alpha x into c1 cos beta x plus c2 sin beta x. Okay. In this case, alpha is equal to 0 and beta equal to 1. So you are having e raised to 0x into c1 cos x plus c2 sin x. Since e raised to 0x is 1, the solution is c1 cos x plus c2 sin x. Now we have found the solution of the corresponding homogeneous part, that is we have found YH. Now we have to find the particular integral, that is YP. So since your right hand side is sine 2x, the choice of yp should be a cos 2x plus b sin 2x. Okay. Now, even if suppose your right hand side was cos 2x, then also the choice of yp will be a cos 2x plus b sin 2x. I hope that is clear. Even if it is sine or cos, the choice of yp is the same. It is a cos omega x plus b sin omega x. Okay. Now, next step is we have to find yp dash and yp double dash. Since your yp is a cos 2x plus b sin 2x, yp dash comes out to be minus 2a sin 2x plus 2b cos 2x, and yp double dash comes out to be minus 4a cos 2x minus 4b sin 2x. Now the next step is you have to substitute this yp and yp, that is yp dash, yp double dash, etc. in the given ordinary differential equation. So it actually becomes yp double dash plus yp equal to sin 2x. Now yp double dash is found here, yp is also found here. Now adding those, you get it as minus 3a cos 2x minus 3b sin 2x is equal to sin 2x. That is, equating both sides, you get minus 3 equal to 0 or a equal to 0. And that is, we are equating coefficients of cos 2x on both sides. Now we are equating coefficients of sin 2x on both sides. So you get minus 3b equal to 1 or b equal to minus 1 by 3. So your yp comes out to be minus 1 by 3 sin 2x. That is because your yp is a cos bx plus b sin bx, a cos omega x plus b cos sin omega x, and your a is 0, b is minus 1 by 3. So your yp is minus 1 by 3 sin 2x. Okay, so the general solution is YH plus YP, that is the general solution is C1 cos 2x plus C2 sin 2x, that is, this is your YH, we have already found this, plus YP is minus 1 by 3 sin 2x. This is your general solution of the given ordinary differential equation. Okay, I hope that is clear. Now we will move on to the next case. The next case is, suppose your right hand side is a combination of exponential function and cos. That is, if it is k e raised to ax into cos omega x, or suppose if it is k e raised to ax into sin omega x. Suppose if it is like this, then what to do? Okay, for example, it can be e raised to 2x into cos 4x, or maybe e raised to x into sin 2x, something like that. In that case, the choice of yp should be e raised to ax into a cos omega x plus b sin omega x. Here a and b are arbitrary constants. We have to find yp dash and yp double dash, substitute in the given equation, and then find capital A and b. Small letter a, omega and omega are available, will be available with us. Okay, so I'll illustrate that with the help of an example. Okay, you look at this question here. The question is d square plus 2d minus 3 operating on y is equal to e raised to x cos x. This is actually yp double dash plus 2yp y double dash plus 2y dash minus 3 equal to e raised to x into cos x. First we will just find the corresponding yh, that is the solution of the corresponding homogeneous equation. So the corresponding homogeneous equation is nothing but you just take the right hand side to be equal to 0, and then you have to replace y with 1, y dash with m, and y double dash with m square. So the characteristic equation becomes m square plus 2m plus minus 3 equal to 0. The roots of the characteristic equation are minus 3 and 1. Hence, the solution will be c1 e raised to minus 3x plus c2 e raised to x. This is the solution of the corresponding homogeneous part, and that is your yh. Now we have to see how to find yp, the particular integral. Okay, to find the particular integral, since your r of x is e raised to x into cos x, the choice of yp should be e raised to x into a cos x plus b sin x. Remember, the general method is if your r of x is e raised to ax into cos omega x, then your yp should be e raised to ax into a cos omega x plus b sin omega x. Here small letter a is 1 and omega is 1. So your yp should be e raised to x into, you don't have to bother much about that. If your solution, if your r of x is e raised to x into cos omega x, your yp should be e raised to x into, instead of cos x, you take it as a cos x plus b sin x. Okay, now you find its two derivatives, yp dash and yp double dash. That has been done here. So yp dash, it comes out to be, first I am taking derivative of e raised to x, that is written here, then into second term. Okay, next what we are doing is we will be writing e raised to x into derivative of this term, that is what is written here. Now that in simplified form comes out to be e raised to x into a plus b times cos x plus b minus a times sin x. In similar terms, you will have to find yp double dash also. Yp double dash comes out to be e raised to x into 2b cos x minus 2a sin x. Now what you have to do is you have to substitute all these in the given ordinary differential equation. That is, your given ordinary differential equation is y double dash plus 2y dash minus 3y equal to e raised to x cos x. So instead of y, we are substituting yp. Instead of y dash, we are going to substitute yp dash, and instead of y double dash, we are going to substitute yp double dash. So yp double dash minus plus 2y dash minus 3y equal to e raised to x cos x. That is what is evaluated here. Now what you have to do is you equate both sides. That is, on the left hand side you have e raised to x into cos x. So all the coefficients of cos x, you take it together, that comes out to 4b minus a, and that you have to equate it as 1. It is 1 times e raised to x cos x. Now similarly, you take all terms involving sin x together. The coefficient of sin x, e raised to x into sin x, there is no term involving e raised to x into sin x, so it is 0. So you equate that coefficient of sin x as with 0. Now from these, solving these two equations simultaneously, you will get a as minus 1 by 17 and b as 4 by 17. So your yp, that is your particular integral in this case, is e raised to x. That is, remember your solution was e raised to x into a cos bx plus b sin bx. So your solution will come out like this: e raised to x into minus 1 by 17 cos x plus 4 by 17 sin x. Now combining your yh and yp, you will get the general solution. that is the general solution is yh plus yp. Yh is c1 e raised to minus 3x plus c2 e raised to x, and yp is e raised to x by 17 into 4 sin x minus cos x. I hope that is clear. Now we will move on to the next case. The next case is, suppose your right hand side is a polynomial. It can be something like kx raised to n, or any sums of terms like that, a polynomial like x square plus x, anything of that sort. In that case, what we have to do is, suppose if your right hand side is kx raised to n, then you have to, your choice of yp will be kn x raised to n plus kn minus 1 x raised to n minus 1 plus etc. k1 x plus k0. That is, if your right hand side is kx raised to n, you have to replace that with the expression of a general polynomial of degree n, okay, with all terms. So that it will be better if I illustrate with an example. Just for example, suppose if your right hand side is x raised to 4, then you have, your choice of yp should be k4 x raised to 4 plus k3 x cube plus k2 x square plus k1 x plus k0. Okay, now we look at a problem here. Now in this given question, your given differential equation is y double dash minus 2y dash plus 5y equal to x square. So as usual, we will solve the corresponding homogeneous part. We will take the right hand side to be equal to 0. Your characteristic equation or auxiliary equation comes out to be m square minus 2m plus 5 equal to 0. The roots of the characteristic equation are m equal to 1 plus or minus 2y. So the general solution, that is the solution of the corresponding homogeneous part, will be e raised to x into c1 cos 2x plus c2 sin 2x. You should have studied how to solve the homogeneous differential equations by now. So this part is done. Now we have to move on to our part, that is, we have to find yp. Now how to find yp? Your right hand side here is x square, so you should your choice of yp should be a general polynomial of degree 2. So a general polynomial of degree 2 will be something like this. It is k2 x square plus k1 x plus k0. So you should, that should be a choice of yp. So yp dash, it is 2k2 x plus k, yp double dash is 2k2. Now substitute all those in the given differential equation. The given differential equation is y double dash minus 2y dash plus 5y equal to x square. So substituting, you will get yp double dash minus 2yp dash plus 5yp equal to x square. That comes out like this. Okay. Now what you have to do is, you have to equate coefficients on both sides. That is, here coefficient of x square is, remember the coefficient of x square is 1 here. So the coefficient of x square on the left hand side is 5k2. So equating those two, you will get 5k2 equal to 1 or k2 equal to 1 by 5. Now the next term, the on the right hand side is, there is no term involving x. So the coefficient of x is 0. But on the left hand side, the coefficient, there is coefficient of x. The coefficient of x is 5k1 minus 4k2. So that you have to take it as your second equation. Okay. That is that you have to take it as your second equation. And then the third equation will be, you have to equate the constant terms on both sides. Then the constant term on the right hand side is again 0. The constant term on the left hand side is this 2k2 minus 2k1 plus 5k not equal to 0. Okay. Now you solve these three equations. So the first equation is 5k2 equal to 1, which is which I get by equating coefficients of x square on both sides. So that from there I get k2 equal to 1 by 5. The second equation is minus 4k2 plus 5k1 equal to 0, which I get by equating coefficient of x on both sides. And from there I get k1 equal to 4 by 25, since we have already found k2 as 1 by 5. Now the third equation is 4k2 minus 2k1 plus 5k0 equal to 0, which I get by equating the coefficients of, actually that is equating the constant terms on both sides. So from there I will be able to find k0, because we have found k1 and k2 already. Now you remember your general, that is your choice of yp was k2 x square plus k1 x plus k0. So substituting all those terms here, you get yp like this. This is your particular integral. Now we have to write the general solution as y equal to yh plus yp. That is, y will come out to be e raised to x into c1 cos 2x plus c2 sin 2x plus 1 by 5x square plus 4 by 25x minus 2 by 125. Okay. Now we have done. That is, from this is your yh, this is your yp. So, taking the sum of both, you get the general solution. Now we have covered all the cases. Now next, what we are going to look at a special case. That is, we are going to look at a note here. This is first I'll read that note. That is, if a term in your choice of yp happens to be a solution of the homogeneous ordinary differential equation, then multiply this term by x or by x square if the solution corresponds to a double root of the characteristic equation of the homogeneous ODE. Now this note I'll actually explain with some examples. So for example, in this given question, what is the right hand side you have? You have the right hand side as 2 e raised to minus x. Now suppose, and your yh you are actually getting it as c1 e raised to minus 2x plus c2 e raised to minus 3x. Suppose if your right hand side here, suppose it was 2 e raised to say minus 2x. Suppose if that was your right hand side, then the problem is your right hand side is involving e raised to minus 2x, and in your yh also one solution is e raised to minus 2x. So here you will have a problem. If suppose your right hand side was not e raised to minus x, suppose if your right hand side was e raised to minus 2x, then the choice of yp will not be c e raised to minus 2x. The choice of yp will be c into x into e raised to minus 2x. The reason is e raised to minus 2x is already a solution, a part of your solution. That is it is a solution of your homogeneous part. So when you take yp, you should take it as x into e raised to minus 2x. Okay, because that has already been a part of your yh. That is what that note suggests. I'll repeat once again. In this same question, suppose instead of e raised to minus x, suppose you had e raised to minus 2x. Okay, then what happens is you already have e raised to minus 2x in your yh. In that case, your choice of yp should not be c into e raised to minus 2x. It should be c into x into e raised to minus 2x. Okay. Now suppose if you had repeated roots here. Suppose here your root was, say, the characteristic equation was, say, m plus 2 the whole square equal to 0. Then what will happen is you will have your solution yh as c1 into e raised to minus 2x plus c2 into x e raised to minus 2x. So your e raised to minus 2x is a double root of your yh, double root of your homogeneous equation, and it is also your r of x. So in that case, your yp should be x square into e raised to minus 2x. Okay, so that you should take care. So these things are there in the notes that are uploaded. So you just go through those problems and solve all those questions one by one. Thank you.